All right. In this video, I want to go over one example of a substitution problem that's a little bit more challenging than the other ones that we've seen. And we can see how we can use a technique to integrate even more functions that might not be obvious as far as substitution goes. So here we have the integral of the square root of 1 plus x squared times x cubed dx. Now, we have a composition here, the square root of 1 plus x squared. And in the past, we would use that for our substitution. We would let u be 1 plus x squared, and then du is 2x dx. But we have a little bit of an issue here. We don't have 2x dx in our integrand. We don't even have x dx. If we wanted to divide both sides by 2 and write this as 1/2 du equals x dx, then it still doesn't really work out because we've got x cubed dx, but we need x dx. However, not all is lost. We actually can proceed with this. What I'm going to do is I'm going to take the integral and we're going to take that x cubed dx and we're going to split it up into two different things. We're going to write that as x squared times x dx. Now, the helpful thing here is that we have x dx in the integrand, which matches what we have up here. And we know that we're going to be able to replace 1 plus x squared with u. So both of these things we can translate from x to u. Now, you might be thinking there's still an x squared there, but if we look at our original substitution, where u is 1 plus x squared, if we subtract 1 from both sides to get x squared alone, that means x squared is u minus 1. And once we've done that, we can replace this x squared with u minus 1. And so we can actually write everything here in terms of u. So let's go ahead and do that. When we make the substitution, the square root ends up becoming the square root of u. The x squared becomes u minus 1. And then the x dx becomes 1/2 du. So I'm going to put the 1/2 out front and then du in there. And this maybe looks a little tricky, but what we can do is we can distribute that square root of u, and we can write both of the terms as powers of u. So here, when we take root u times u, well, that's u to the 1/2 times u to the 1. That's going to end up being u to the 3/2. And then minus the square root of u times 1 is the square root of u, which is the same as u to the 1/2. And once we've written each term as a power of u, we can go ahead and we can use the power rule. So the integral of u to the 3/2, we can add 1 to the exponent. So that's going to be u to the 5/2. And dividing by 5/2 is the same as multiplying by 2/5. So let's go ahead and do that. And then minus the integral of u to the 1/2 is u to the 3/2 over 3/2. And that's the same as times 2/3. And I'm just going to put that constant out there at the end. If we distribute the 1/2, we end up getting 1/5 u to the 5/2 minus 1/3 u to the 3/2 plus our constant. And then finally, we can go back and wherever we see a u, we can replace it with 1 plus x squared, our original substitution. And we end up getting something that's only in terms of x And that ends up being our integral. It's not the prettiest thing in the world, but it is a function of x, and it was not that difficult in the end. So this is an example of a situation where we can use the substitution rule. We can use substitution with our composition of functions by setting u equal to the inner function, but we might have to split things up in the other factor so that we can manipulate things and make this work out. In this problem, it would work if we have x cubed. It would also work if it was x to the fifth, because if we had x to the fifth, we could write that as x squared times x squared times x dx. I'm going to shove that dx in there. And then we know x squared is u minus 1, and then the other x squared is u minus 1, and then the x dx was 1/2 du. Basically, as long as it was an odd power of x here, we could break off a bunch of x squares and write them all as u minus 1s. If this was an even power of x, like x squared or x to the fourth, we actually couldn't do this, wouldn't really work out in the same way, and so we would need to use a different strategy at that point. But for this problem, so long as we have any odd power of x, we can go ahead and do that, so we can write it all in terms of u.